Alright, so this video is all about how to factor using the greatest common factor. So if you remember, greatest common factor means basically we're trying to find the biggest factor that's the same. Okay. So we're going to start with this first problem over here on the left. As you can see, we have two terms. So our table is only going to need two sections. And then we're going to need a section for our number, our coefficient. And then we're going to need a section for x and a section for y. So that's kind of how we determine how many sections that we need for our table. So the first one, I'm going to use pink to distinguish what I'm doing. First, we need to find the factors of 21. Put up the thickness a little bit. So for 21, the factors are 1 times 21 and 3 times 7. Then we can see there are 4 x's and 3 y's. 1, 2, 3. Next, we're going to do the same thing for our other term. Do it in blue here. First, we need to find all of the factors of 35. So that's 1 times 35 and 5 times 7. And I believe that those are all the factors of 35. So then what we need to do is list out all of our x's that we have. We have 3 x's. And here, remember, if we don't have an exponent, we can put a 1. So we have 1 y. Next, we're looking for our greatest common factor. So as you can see, both of these factors have a 1, and they also both have a 7. We're looking for the biggest one that's the same, so we are going to go with 7. On our quiz, I noticed a lot of you had the right method, but you missed some factors or something when you were making it. I would really make sure that you list out all of your factors in a list and double check that you haven't missed any factors. So we have 7. And then if we look at our x's, we have 1, 2, 3 x's in common. Now recircle those. 1, 2, 3. So 7x 3, because we only count those x's one time. Then we're going to pull out 1 y, because that's the most y's we can get from both of them. Next, you'll notice we have a subtraction sign here. So that tells us that we're not quite done, because we need to see what would be left. So I'm going to put our parentheses down, and I'm going to put a subtraction sign like we have above. Then I'm going to highlight what would be left. If we divided 21 by 7, we would have a 3 left over. And if we took 3 x's from 4, we would have 1 x left over. And it looks like we have 2 y's left over as well. So 4xy squared. On the bottom, if we divide 35 by 7, we have 5 left over. And we have no x's and no y's left over, so we just have 5. So this would be our final answer. We factored the greatest common factor from our original expression, and this looks good. Remember, if you did want to check your answer, you could redistribute your answer. So we would just multiply and make sure that we get 21x4 y3 minus 35x3y. Check. That looks good. Okay. I'm going to shrink this down so we have space for our next one, which is going to be a little bit extra work. That's okay. So if we look at this one, the only main difference here is that we have a z as well that we need to look at. So that just means when we draw our table, we're going to need to have an extra spot for our z's to be looked at as well. But it still starts the same. We're going to look at this first term here. Factors of 64. 1 times 64. 2 times 32. 4 times 16. And 8 times 8. That should be it. We have 3 x's, 2 y's, and 5 z's. Let's try that again. 1, 2, 3, 4, 5. And then on the bottom we have this term. So let's start by listing the factors of 80. 1 times 80, 2 times 40, 4 times 20, 5 times 16. That's a hard one to remember. But remember, it ends in 0, so it has to be divisible by 5. And then 8 times 10. 2 x's, 1 y, 3 z's, 2, 3. So if we look, our biggest number in common is actually 16. We have 2 x's in common, so 16x squared. 1 y, and 3 z's in common. I like to circle them because it helps when you're looking for what's left over. It looks like we have subtraction, so we're going to subtract. And we have 64 divided by 16, 4, 1x, 1y, 2 z's. So 4, one x, one y, two z's. On the bottom we have 5, and that's it. Nothing else left. So our final answer is 16x squared yz cubed 4xyz squared minus 5. Okay. Our last problem is kind of a special case type of problem. For this one, we are going to factor using the greatest common factor, and then we're going to factor into binomials. So here we have 3 terms. 1, 2, 3. So when we set up our table, we're actually going to have 3 spaces for our terms. So I'm going to put the factors of 5 in the first box, along with 3 x's. Then I'm going to put the factors of 30, 1 times 30, 2 times 15, 3 times 10. So we need a little more space. And 5 times 6. And we have 2 x's with that one. And then in the last box, we're going to put 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8, and 1 x. So our greatest common factor here would be 5. And then it looks like we can only get 1 x from the rest of those. So up here we have a minus and a plus, so that's what we're going to put in our parentheses. On the top, it looks like we have 1 and 2 x's left over. Then we have 6 and 1 x left over. And lastly, we have an 8 and no x's left over. And we can rewrite this without, wow, that was a terrible arrow. We can rewrite this without our 1 here in front of the x squared, because 1 times anything is just the same thing. So we just have x squared minus 6x plus 8. So we already factored by the greatest common factor. Now we need to separate it into binomials by factoring our trinomial. Because right now we have 1, 2, 3 terms. That means it's a trinomial. We want to get it into binomials by factoring even more. So I'm going to draw our area model box. I'm going to put x squared into the first box and 8 into the last box. Draw a little diamond here. We could think of this as 1x squared. So the top is just going to be 8 times 1, or 8. And in the bottom, we're going to put this term here, negative 6x. So we're looking for two numbers that multiply to positive 8, but when you add them, it's still negative 6x. That's going to tell us that both of our numbers need to be negative. So our options are negative 1 times negative 8, which is 8, or negative 2 times negative 4, which is also 8. If you notice, negative 2 plus negative 4 is negative 6x. So those are the numbers that we need to use. So we have negative 2x and negative 4x. The only things that we can use to multiply to get 1x squared is just x times x. X times negative 2 is negative 2x. And x times negative 4 is negative 4x. So our very, very, very final answer, we need to put this 5x in front still. Then we have x minus 2 times x minus 4. So we started with this, and we went all the way into this using greatest common factor and just factoring. Yay! I hope you guys are having a wonderful, wonderful day. Please look at the next practice assignment for what you should do next. Thanks. Bye.